Now let's just start with arithmetic progression. That what is an arithmetic progression? So before the actual definition, let's just observe some list of numbers. Let us suppose I'll have 1, 2, 3, 4 and we will have 100, 70, 40, 30 and so goes on. Similarly, if I'm talking about -3, -2, -1, 0 and so goes on. So I can see in all these terms or all these list of numbers, each of the numbers are actually in this list is called as a term. Always remember that whenever we have such kind of the list of numbers, then each and every number is actually called as a term. So -3 is a term, -2 is a term, -1 is a term, 0 is a term and so goes on. So how we can relate these numbers with the arithmetic progression? So let us suppose if I'll repeat these numbers again, we have these three lists. So succeeding terms are actually obtained by adding a fixed number to the preceding terms. You can see over here that if I am talking about 1, 2, 3, 4, so the succeeding term is obtained by adding a fixed number to the preceding term, and such numbers is set to form an arithmetic progression. So such type of numbers always form an arithmetic progression. So if I'm talking about the general definition of an arithmetic progression, so an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So we always leave the first term and we always start from the second one, and we can say any list of numbers in which each term is obtained by adding a fixed number to the preceding term, then this list of numbers always forms an arithmetic progression. This always forms an arithmetic progression. So if we are talking about the Reena's salary, so Reena's salary was actually nothing but an arithmetic progression, because the whole numbers are following this pattern, that the succeeding term was actually obtained by adding a fixed number to the preceding term. Now let us suppose if I'm talking about that fixed number, because here we are talking about adding a fixed number to the preceding term. So that fixed number is actually called as the common difference. The fixed number do have a special name which is called as the common difference of an arithmetic progression. Always remember, arithmetic progression in short can be written as A dot P, which means arithmetic progression. So here we can take an example of the Reena's salary, that 8,000, 8,500, 9,000, 9,500, so goes on, is nothing but an arithmetic progression in which the fixed number or the common difference that we are adding is nothing but 500. That is nothing but 500. And again, there is a special note which is related with the common difference, that the common difference can be positive, it can be negative, it can be 0 as well. Because if I'm taking the list of numbers as 1, 2, 3, 4, as you can see over here that the number over here we are using is nothing but 1, 1, 1, 1, 1 and so goes on. So the common difference can be positive, common difference can be negative, common difference can be 0. Means the fixed number can be positive, can be negative or can be 0. So this is a very really important concept in which we are talking about the definition of an arithmetic progression, that what is an arithmetic progression and what is a fixed number which is called as the common difference, and common difference can be positive, can be negative and can be 0. Now let's just talk about in general how we can represent it. Let us suppose if I can say I am representing the arithmetic progressions, first term as A1, second term as A2, third term as A3 and so goes on. So let us suppose if I am taking the arithmetic progression in such a way that I am taking the first term as A1, the second term as A2 in general, the third term as A3 and the last so goes on term as AN. So let if this is my first term, this is my second term and so goes on, this is nothing but my nth term. This could be any term, that's why I'm considering it as nothing but the nth term. So hence we can here see that whenever we are talking about the arithmetic progression, so we can obtain the succeeding term by adding a fixed number to the preceding term. So it means that if I'll take the difference of the succeeding as well as the preceding term, I will get the fixed number. Let us suppose if I'm talking about this, so if I'll say I'm taking a2 minus a1, means the difference of these two terms. If I'll take the difference of these two terms, or if I'll take the difference of any two consecutive terms, they always comes equal to a fixed term. They always comes equal to a fixed term or a fixed number. That is nothing but called as the common difference. So actually this D represents the common difference. Always remember, small d, capital D always represents a common difference. So in general, we always represent the common difference as nothing but small d. So always remember, small d is nothing but that fixed number that we always add in the preceding term to get a succeeding term. So this d is representing the common difference. Moreover, we can write the formula for the common difference as nothing but ak plus 1 minus of ak, which means we can calculate the common difference by subtracting the succeeding term with the preceding one. So this is the common difference, which is all related with an arithmetic progression. So always remember, whenever we are talking about the arithmetic progression, so it means that the difference of any two consecutive terms is always the same. The difference of any two consecutive term. For an instance, if I'll again take the Reena's salary, we have 8,000, 8,500, 9,000. If we'll take the common difference, or if we'll take the difference of any two consecutive terms, we always get the answer as nothing but 500, and that 500 is nothing but the common difference, which is represented by this small d. This small d represents the common difference. Now let us suppose if I am further talking about an example, which is 10, 20, 30. Now we can see that this is an arithmetic progression. Why it is an arithmetic progression? Let's just see why it is an arithmetic progression. We know that in an arithmetic progression, we can say the succeeding term is always obtained by adding a fixed number to the preceding term. Now we can check this out by taking the subtraction of any two consecutive terms, whether they are coming equal or not. So let us suppose if I am taking a difference of 20 and 10. So if I'll subtract 20 minus 10, always remember to take the succeeding term first and then the preceding term. If I'll take the difference of 20 minus 10, this is nothing but 10. Again, if I'll take the difference of 30 and 20, 30 minus 20 is nothing but 10. So here we are getting the difference as same. Here we are getting the difference as same throughout, which is nothing but represented as D. So the common difference over here is nothing but 10 everywhere. And whenever we have such a terms in which the difference of the two consecutive terms comes out to be equal, this represents an arithmetic progression. So hence this is an arithmetic progression. Now let's just see how we can represent these terms into a very special manner. So let us suppose if I have this 10, let us suppose if I am writing this 10 first, as we can write 10 as let us suppose as it is 10. Further we have 20, so we can write 20 as nothing but 10 plus 10. We can write 20 as nothing but 10 plus 10. And further we have 30, so we can write it as 10 plus of 2 into 10. We can write it into this particular formation. And in the similar manner, if I'll move on further, I can write it as 10 plus 3 into 10 and further, and so goes on. So here you can see I am actually following a certain kind of a pattern, and the conclusion that I am getting from here is nothing but A plus D, A plus 2D, A plus 3D actually represents an arithmetic progression in general, where A is the first term and D is the common difference. So here you can see, if I am considering this arithmetic progression, this is my very first term which is representing A, and this is my common difference which is representing D. So in general, if I'll represent all these progressions, so I can write it as A, I can write it as A plus D. As you can see, we can write it as nothing but A. We can again write it as nothing but A, and this is nothing but my D. This is again my A, this is again my D. So I can write it as A plus 2D. I can write it as A plus 3D. D, and so goes on. So in general, we represent the terms of, because these are called as the terms, we represent the terms of an arithmetic progression as nothing but A plus D, A plus 2D, A plus 3D, and so goes on, where A represents the first term, D represents the common difference. So this is all about the general representation of the terms of an arithmetic progression and some of the examples and the definition which is related with the arithmetic progression.